Titanium is stronger than steel, but weighs half as much. It survives jet engines at 1,000 degrees. It sits inside your body for 50 years without your immune system even noticing. But here's the twist most people never get. Titanium is actually one of the hardest metals on Earth to make, not because it's rare, but because of one brutal chemical problem. Stick around. By the end of this video, you'll know exactly how a pile of dirt becomes the metal that flies to Mars. Titanium is the 9th most abundant element in Earth's crust. It's everywhere, in soil, in rocks, even in the paint on the walls around you. So why isn't it cheap like iron or aluminum? Because titanium has a temper. The moment it gets hot and meets oxygen, it becomes brittle, weak, and useless. You can't just melt titanium or in a furnace like iron. If you try, oxygen ruins it instantly. So how do you melt a metal? The answer took chemists decades to crack. It's called the Kroll process. And it takes almost a week to make just one batch. Keep that number in your head. 1 week. By the end, you'll understand why that's actually the fastest anyone has ever managed to do this. It starts with 2 minerals, ilmenite and rutile, mined from beach sands and rock deposits in places like Australia, South Africa, and Canada. These ores are crushed, washed, and separated using magnets and density. Heavier titanium-rich particles sink, lighter waste floats away. What's left is a dark, sandy concentrate called titanium dioxide. The same compound, ironically, that's used in sunscreen and white paint. Strange thought. The same white powder protecting your skin from the sun is one step away from becoming a fighter jet, but turning it into metal is where things get intense. The titanium dioxide is fed into a chlorination reactor with coke, nearly pure carbon, and blasted with chlorine gas at over 900 degrees Celsius. This chemical reaction strips away the oxygen and leaves behind a new compound. Titanium tetrachloride, nicknamed tickle by workers because of its formula, TiCl4. It's a colorless liquid that fumes violently the second it touches open air. Handled wrong, it's dangerous. Handled right, it's the key that unlocks pure titanium. But here's the part almost nobody expects next. This liquid still isn't metal. It has to be broken apart using something you'd never guess, another metal in liquid form. Now comes the real transformation. The titanium tetrachloride is pumped into a sealed steel reactor filled with liquid magnesium in an atmosphere with 0 oxygen, because even a trace of it would ruin the entire batch. At around 850 degrees Celsius, the magnesium rips the chlorine away from the titanium in a fierce chemical exchange. What's left behind is a spongy, porous mass of pure titanium metal, appropriately called titanium sponge. Here's the detail that surprises even engineers. This single reaction can take several days to complete. There is no shortcut, no faster furnace, no industrial hack ever found in over 70 years of trying. This slowness is the exact reason titanium costs so much more than steel, and the exact reason no cheaper method has replaced it since 1940. The titanium sponge is crushed, cleaned, and blended with alloying elements like aluminum or vanadium, depending on whether it's headed for an aircraft wing, a hip implant, or a wedding ring. It's then melted in a vacuum arc furnace, where an electric arc, hotter than lightning, melts the metal without letting oxygen anywhere near it. The molten titanium is cast into massive cylindrical ingots, some over a ton in weight, then forged, rolled, or machined into sheets, rods, and precision parts. Somewhere between that glowing ingot and the phone or watch in your pocket, this metal has to survive dozens more steps, and almost none of them can go wrong. Think about that journey for a second. Beach sand, chlorine gas, magnesium, days of reaction time, vacuum furnaces hotter than volcanoes, all of that. Just so a bike frame can be lighter, a jet engine can survive extreme heat, or a titanium implant can sit safely inside a human body for decades without rejection. And here's the part that should really stick with you. Humanity has known how to do this since the 1940s and still hasn't found a faster way. Hit the subscribe button and like the video for more.